This is a general introduction into trigger validation shifts. Here we're looking at the main wiki for trigger validation, and you should definitely read it at least once before your first shift. So why do we need trigger validation shifts? Well, there are multiple versions of Athena that are being developed in parallel by basically hundreds of developers, and they pretty much commit code on a daily basis. So our task is to ensure that none of those commits break critical functionality, and if they do, that we quickly report this back to the developer who was responsible so that they can address any issues. So the multiple versions of Athena are called nightlies in the context of trigger validation shifts. Somewhere on this wiki there is a link to the NICOS global page, which I have open here. So we're looking at a list of different nightlies. For the trigger validation shifts, you don't need to report errors in all of those nightlies. If you scroll down on this wiki, there is a list of relevant nightlies, and this list may be updated from time to time, so you should keep an eye on it. So let's go back to the NICOS global page. And let's choose one particularly important nightly, the P1 HLT. So I'm going to click this link here. Next, we're offered a choice between the debug compile and the optimized compile. For the trigger validation shifts, we always focus on the optimized compile. So I'm going to click this link. Okay, now we see 7 links corresponding to 7 days of the week. So what this means is that there is a bunch of tests that are automatically performed on a daily basis, and this page keeps track of the last 7 days. The convention here is that rel 0 is Sunday, whereas rel 6 is a Saturday, with all other days in between. So if we look at today, we're in Chicago, and it is Saturday Chicago time, and that means that rel 6 has already finished running and its results are available. Rel 0 is Sunday, and it's actually already Sunday at CERN, and you can see that it's in progress right now. So let's instead look at rel 6 because we know for sure it's been finished. By the way, you should click this link in the green box under test success. So we go here, and what we have is a list of different tests that were run automatically for this particular nightly on Saturday, on rel 6 day. Most of the tests succeeded, and they don't need any attention from us. There are a few tests that have warnings, and there are a few tests that have fairly severe errors. So let's click on this first test called OLMTMC run stop run. If we click it, we get to a page that has some fragments from the log from the job that ran this test. If you scroll down to the bottom, you see a bunch of error messages, and that's what we need to report and make sure the expert fixes it. So here we very quickly found what looks like a relevant segment. There's a very characteristic set of error messages. They're all labeled with big error word, so that's fine. Let's look at another test, the third one here, trigger DBA access test. So if we click it, we go to a similar page, but now if you scroll down, you don't see any characteristic fragments in this log. It's not immediately evident what went wrong. So what do we do in this case? Well, if we go back and scroll to the right our browser window, there is another link here to the workdir. So if we open it in a new tab and then go there, we're presented with another table that contains the same set of tests that we saw in this original page from NICOS, but it provides additional links for every test. So let's look at this trigger DBA access test. So I'm going to use the Control F search in my browser window, and here I've located this test on this page. So here, in addition to this link that we looked at before that didn't have anything obviously relevant, we have a number of additional links. So let's start with this one. I call it the log extract. It is basically a section of the log that often contains a relevant fragment that you may not always find in this NICOS section. In this case, however, we're looking at it and we're again not seeing anything obvious. So we're going to close this link and go back here. Here on the right, there are two more links. So the ATN test log link contains the full log from the job that ran this test. Sometimes it's very large. It may crash your laptop, so I don't recommend opening it. But next to it there is a tail link that is exactly what it says. It's last few hundred lines from the full log, and it's usually a very useful link to look at. So if we do look here, we now see something relevant, and we see there is a problem. The error, HLT menus are not identical, and then a cause, there is a certain XML file missing. So now, as a shifter, you've identified a problem in this test. What do we do next? Well, there is a Savannah Bug Tracker. Here is the URL that contains all previously reported bugs. Let's see if this bug has already been reported. So this looks like a unique identifying fragment. I'm going to copy it and go back to Savannah. So select bugs in the search box and paste the little thing we selected from the log. So you hit search, and a few seconds later we found the bug. So indeed someone already reported it, and they pasted the log that looks exactly identical to what we have found. So now our job as a shifter is to leave a comment here saying this problem still occurs. And you can see the other shifters have already done a similar job. So I hope it's clear at this point the overall flow of the shift. We look at the list of tests in each of the nightlies. We look at the ones that have some kind of a problem, then we look at some log files here. If nothing is found, we look at the similar logs on this ATN page and eventually find the faulty lines, and then we check in the Savannah Bug Tracker if they have been reported already, and if they haven't, we actually have to submit a new bug, which you can do by going to Bugs, Submit. And then you would need to fill all the relevant fields and then paste the relevant fragment from the log into the big submission window. The reason the shifts are challenging is because there are a lot of tests. In this particular case, not that many have an error, but sometimes a lot of them do. Moreover, we're looking here only at a particular nightly and a particular series of tests. Overall, there are 30 pages just like this one, each one having an independent set of tests and errors. And that's why, if you were to manually go through all of them, it might take you 6 to 10 hours. But you can see already that this whole procedure could be fairly easily automated. And that's what we have done here at the University of Chicago. We've created a set of scripts that manually goes through all the tests that are reported as errors and manually and automatically matches the special fragments from the logs to known bugs in the Savannah. So in the next part of the tutorial I will show how our script accomplishes all of this.